In this video tutorial, we'll take a look at how to spawn PCG based on a texture, as well as transfer attributes from blueprints to PCG. This could be useful for doing animated PCGs, or also have your PCGs update or change during runtime. To begin, I'll create a brand new scene, and I'll want to go to Edit, Plugins, and make sure that if I search PCG, that our Procedural Content Generation Framework is enabled. Next, I'll go into my content browser and I'll right-click and create a brand new blueprint class. I'll make this blueprint class an actor, and I'll call it something like BP_PCG animated. We're going to make our PCG slightly animated with some parameters that will change over time. Now, once I've done that, I'm going to open up this blueprint. And in our blueprint, there's going to be a few things that we have to add. We're going to go over here to components, and we're going to add, first of all, two important things. The first important thing that we're going to do is under our default scene root, we're going to add a box. And this box will say it's a box collision. That's what we're going to add, but it's really just going to be used for the bounds of where our PCG will spawn. So we'll leave that as box. And then we're also going to add a PCG component. So we're going to go here and just add this one called PCG. And we'll let that just sit here. And that's what we're first going to do to create our actor or our blueprint that will contain our PCG and its bounds. Next, under this PCG component, we're going to click on it. And when we go over here on the details to the instance and the graph, this is the PCG graph, the graph that's going to drive the PCG in this blueprint. We're going to go there and click down on it. And we're going to click new PCG graph, or just create new asset PCG graph. You can also do this through the content browser. Now, once we've done that, we're going to have to give a name for this PCG graph. So I'm just going to call this something like maybe PCG underscore points from texture, since we're going to do our PCG points based on a texture. And then I'll click save. And then I'll double click this graph that we just created to open it up. And here's our PCG graph that we just created called PCG underscore points from texture. Now in this PCG graph, I'm going to right click and I'm going to create a get texture data node. That's going to allow us to get texture data from a texture. We'll have to define the texture, and I already have one that I'm going to use, which is just a sample texture of this kind of logo that I have. So if I click on that, I have this little render bucket logo. And that's what I'm going to use as my sample texture. So that's the texture that I'm loading in here. And then you can kind of filter it out based on a certain channel, either alpha, red, green, or blue. So what we're going to actually do for this is leave it to alpha, because this texture here does have the alpha channel. If I go in here and I look at alpha, it's solid, so the whole thing's going to show up, but there is an alpha channel. And then there's the blue channel, the green channel, and the red channel. And by doing that, if I go in here and have this alpha, I have the ability to set the texel size. And this texel size, if you hover over it, it's a size of one texel in centimeters. So it's pretty much how big each pixel to pixel is in world space in centimeters. So for now, I'll leave this as 50, but we'll probably have to adjust that a bit later to get the proper sizing of PCG points from this texture. The very first thing I like to do is just to get something working, so I know that nothing's broken and that I'm understanding how things actually work. So first thing I'm going to do, just to make sure we can get some output, is I'm going to take this texture data node and take the output and do a static mesh spawner, just so we can see what points we get out of this at the moment. And for this static mesh spawner, I'm going to select a geometry, which will just be a cube. So I'm going to go here under mesh selector, mesh entries. I'm going to add a mesh entry. I'm going to open it up. I'm going to open up the descriptor, and I'm going to set the static mesh here to just be the default PCG cube. And once I've done that, I can then click save, and we'll see what we get. Now, before we can actually have this show up in our scene, we have to make sure that this PCG graph is saved. We have to also go back to our blueprint where this PCG graph is being used in our PCG component. And we're going to have to make sure we compile our blueprint graph and save it as well. And then what we should also do is set our box size here, or the bounds of our PCG here. So we're going to go to the box collision. We're going to click on it and we're going to set the box extent. And for now, I'm just going to set this to 250 by 250 by 1. And that's because I'm only going to have the PCG points just be very limited in Z, and it's mainly just making up that logo in X and Y. But really, you could change this around a bit, and it's not going to really matter too much at the moment. But I'll just start with that for now. And then I'll click Compile and Save. Now, if we just minimize this and jump into our scene for a moment and drag and drop our blueprint into here, we'll see that everything shows up as a ton of really large cubes. And this is because each of those pixels, when represented as a PCG, are too close together for the size of object that we're using. The object is overlapping a bunch of times. So what we're going to do is just go back to our PCG graph for a moment. And before we spawn our static mesh, we could make our static mesh a smaller object. But in this case, an easy way to do that is I'm going to right click and create a transform points node. And I'm going to connect the graph up to that and then connect it back up to the static mesh spawner. And in the transform points node, I'm going to go to the scale min and scale max and make the size of the object, or the size of the points, which will then make the size of the object copied to the points much smaller. So I'm going to set it to something like 0.09, and I'll do that for all scale minimum and scale maximum as well, and save. And then if we go back and take a look at what we have in our scene, things are spaced out quite a bit more, but maybe there's not enough points now to really see the object that we should be getting. So we'll have to increase the amount of points. So what we're going to do to make that happen is we'll go back to our PCG graph, we'll go to our get texture data node, and instead of the texel size being 50, we're going to set it to 10, and then save. And then if we take a look, that's a lot more points. That's a lot more cubes being generated from our image. Now we'll notice that these cubes aren't cut out. They're all displayed in that solid box. And that's because if we look at our texture, the alpha, which is what we're sampling, is completely solid. So if I were to sample only the blue channel, then we'd get more of a cutout. Or if I had a proper alpha channel, then we would get more of a cutout. And maybe just to demonstrate this, if I go back to the PCG graph and I go to our get texture data and I set the density source channel on as alpha, but then change that to blue, it'll cut out to be only the blue pixels that are sampled. But I'm going to leave it at alpha because what I want to do is get this texture's color onto these cubes and see how that would work. So one thing that's very useful for when dealing with PCG is to inspect nodes. You can right click and go to inspect, or just press A, and then you can go down here and make sure you have the PCG selected, and you can see all the data of the points listed out here. So I can see it, there's color RGBA, and that stores the color from that sampled texture. So the info is there if I want to use it. We just need to know how to use it. So the next thing that I'm going to do in here is after spawning these points, which we have now, we can actually get the color from that texture onto those points. Now the way that we're going to do that is go over to our static mesh spawner, and we're going to go to where it says our instance data packer. And for our instance data packer type, we're going to set it from none to PCG instance data by attribute. And then we can have an attribute selector, and we're going to add one, and we're going to make the selector be color. So it will fetch the color data. Next, we're going to go and minimize this for a second. We're going to create a brand new material. I'm just going to call it something like m_PCG material. And inside that material, I'm going to open it up. And for our base color, I'm going to drag it out and create a instance. And you can search instance, and it's called actually a per instance custom data vector 3. So if I do that again, per instance custom data 3 vector, and that will fetch 3 values from whatever custom instance data we have. And in this case, we have from our PCG points here, we have our instance data packer as, color element. And color is red, green, blue, alpha, I guess, but it'll fetch the first 3 values in here. The per instance custom data will fetch the very first 3 packed data values. And you can change that. You can set the data index to a higher number, but by default, it'll bring in 0, 1, and 2. So that would be like our red, green, and blue values. So if I were to do something like that, and then connect this to either base color or emissive color, maybe I'll do emissive color just so we could see it a bit easier, and save that, and then apply this to our PCG. So jumping back over to our PCG graph, what we're going to do is go to our static mesh spawner. We're going to go to our mesh selector, mesh entries, index 0, descriptor. There's our PCG cube that we're creating. We want to override the material. So we're going to add an override material. For that override material, we're going to drop in our MPCG material that we just created. And by doing that and clicking save, we now have our texture on our PCG points, or our colors from our texture applied to the material that our PCG points is using. And if we want these unshaded points, or these points at the edges here that don't really have the texture detail, if we want them removed, we should be loading the sample texture with an alpha. So if I were to go and save that sample texture with a proper alpha, that would be more suited to do that. So as an example, if I were to reload the sample texture with a proper alpha, which I'm just going to do now, you'll see that there we go. It now cuts it out more properly. Now it might not be perfect. And if we were to look at this sample texture and check out its alpha, you could see that now it has a proper cutout here, but your points may not be cut out as accurately. And there's a couple things to fix that. You can make the point smaller, or you can also go to your PCG graph. And in your PCG graph, I'm just going to go here really quickly and show a couple things that might be useful. Under our Get Texture Data node, you can force editor only CPU sampling, and that will kind of change the way it filters the points. You also have the ability to change the actual filter here. So from billionaire to point, you can make that change as well. And then again, texel size. If you want to make the points smaller, you're going to get more accuracy. But that's really up to you, how many points you want, how accurate you want it to be. For now, I think 10 texel size is fine for what I'm wanting. So I'll save that and I'll leave it like that for now, but just keep that in mind. If it's not cutting out exactly the way you want, either modify your alpha or modify those sampling settings. Now, one last thing to remember is if your alpha has slightly semi-transparent sections of it, all our PCG graphs get texture data node is doing is turning that channel that you choose here into density if you have this checked on. So if you do have values that are very low density, one thing that can also help clean up the edges of your alpha and make the cutout better of your texture is to, and I'll just show this both together so we can see this effect, is we can just add a density filter. So if I do a density filter and then connect that to our static mesh spawner, cleans up the points as well. So that can also solve a lot of problems. And you can change your density there to keep more points or clip more points away. But I'll leave it at 0.5, and that seems to clean up that logo much better. Now the next thing we want to do is get these points animating. So to do that, our blueprint's going to become very useful. We're going to open up our blueprint. I'm going to go in here to our variables, and I'm going to add a variable called time. I'm going to make it a float, and I'm going to turn the eyeball on so it's a public variable, and I'll compile and save that. And then I'm going to go to our event graph, and every event tick, I'm going to set that time to record the delta seconds, add it up all together. So I'll grab this time, I'll do set time, event tick, then I'll get the time, and I'll add our delta seconds to our time, and that becomes our new time. And that's what I'm going to do. That's kind of keeping track of the time. And then what I'm going to do is up here on the event begin play, I'm going to do a set timer by function name. I'm going to make a timer called PCG tick, and I'll make it run, not to be wasteful, like maybe every 0.1 second is enough. If you're going to want something updated constantly, PCG is not the way to do it. Probably Niagara effect system would be better. But if you do need your PCG to do some sort of basic animation and you don't have that many points, this might be acceptable. Or if you need your PCG to change when your character flips a switch or a button, then, things like this might be okay. So you have to really evaluate the situation. Now, in this case, I'm going to update it every 0.1 second. We don't have that many PCG points, so it's probably going to be okay. I'm going to loop it. I'm going to set it to max once per frame. And then I'm going to go create this function, PCG tick. So I'm going to go over here to our functions, add a function, call it PCG tick. And once I've done that, I'm going to go to this function here, and I'm going to get our PCG. So I'll drag our PCG in from our components. I'll take our PCG, I'll drag that pin out. I'll click or search for generate and click on generate. And then that will force my PCG to generate. You can turn on the force to make sure it refreshes. And that's just like clicking generate on your PCG. It's like refreshing your PCG. So if anything changed, it will regenerate and redraw everything and evaluate that whole graph again. Now what I'll do is compile and save the blueprint. So all that's good. I'm going to go back to my PCG graph, because now we have to fetch that time variable or attribute. Now in our PCG graph, the very first thing that we're going to have to do to make this work properly is that we're going to have to make sure we get that info or those attributes or variables from our blueprint. So what I'm going to do is I'm going to create a node called getActorProperty. You have to say where you're getting the actor property from. So you could do parent. Now, just to be safe, you should be able to leave this as parent, but I'm going to do include children. And what you can then do is say actor selection by class, and you can choose your actual blueprint. So if my blueprint is called BP underscore PCG animated, I could find that blueprint. Now, you could do that as a failsafe, but technically leaving this at parent and not include children should just be fine. Now, once we've done that, we have to say what property do we want to fetch. So it shouldn't be none, it should be time. So I'm going to fetch time. And that's the same variable we have here, time. Make sure spelling is correct. Now we should be able to get that attribute through our PCG graph, or get that variable through our PCG graph. So now what I could do is take this getActorProperty, connect it up to a sign node. Then after that, I could multiply it just so the values are a bit lower, and I'll multiply it by a constant. Now, if I need to multiply it by a constant, I could just simply do like a placeholder, create attribute, put a value in like 0.1, and just connect that up. And then what do I do with that? I'm going to output that and use that to control the scale of my points. So we have our transform points here. So what I'll do is open that up. What do we want to control? We want to control maybe scale max. So that will be our output. And that should control our scale maximum. And our transform points, there's a minimum maximum. So the points will randomly choose a size between their minimum size and then this maximum size, which will constantly be changing as time passes. And if we were to save that and test this out, we can see our points already look like they're different sizes. And if I were to go up here and go to simulate, we can now see them animating over time. So pretty cool, pretty neat effect. Now there's a bunch of other things you could do to make this a little bit more fancy. I'll give some of those tips here, or at least one of them. In your PCG points, one thing you can also do that might be helpful is use duplicate point. And if you do that, you can duplicate your points in a direction. So I could do iterations, and if we take a look at this, let's have both of these up so we could really see what's going on here. If I take the duplicate point and do iterations 10, you could see how it just stacked the points. 1, 2, 3, 4. Now there's not much distance between them, so maybe I'll do point transform, and I add a Z point transform to like 10, 20, 30, 50, 80, 100, 150. Now, there you go. Now you can see them separate. Maybe 120. And they have like towers of these points. So a lot of cool things you could do with duplicate point, and you could use direction applied in relative space. That might be interesting if you do things like rotations. You can also choose a direction that it's doing that in. So there's a lot of potential here for doing cool kind of patterns really easily. Maybe I'll do, let's see, 90, 90, 90. Yeah, look at that. Get all these twirly kind of cool patterns. So there's a lot of potential there for doing some cool stuff. Yeah, give it a try, see what you can do. And you might be able to get some interesting structures out of it. And make some cool things. So a lot of potential there. And again, since these are all animated, if I were to, simulate, there we go. It's all animating. Now, right now, our sine wave goes up to 1 and then down to -1. So it's doing like a reverse scale. If we didn't want that to happen, maybe I'll just disconnect this for now. If we just had our normal points here, they're kind of scaling up and then they're scaling down and going negative. If you didn't want that, it's really easy. You could just take your sine wave here and you can just go and do something like a add, and you can add an attribute, like create attribute, just add one, and then multiply by 0.5, and then continue with that value. And that pretty much will just make the sine wave go from 0 to 1 instead of -1 to +1. And then by doing that, we should no longer get a negative scale. It just goes down to 0 and then back up to 1. But there you go. You can do some animations with PCG and hopefully now understand how you can pass variables or attributes from your blueprints into your PCG graphs. If you enjoyed this video or you learned something new, don't forget to like and subscribe. And if you're part of the Patreon, which you can find a link to down in the description below, you'll also get access to the PDF for this video, which goes over all the steps you saw in this video in a little bit more detail.